This video is going to cover section 5.1 for UMA statistics, probability rules. Probability is just the chance of a random event happening. Outcomes are the random results. Random results. So for example, if you flip a coin, you don't know it before you flip it if it's going to be heads or tails. So that's a random event. And then probability is just talking about the chances of getting heads or tails, which are the outcomes. The law of large numbers just says that the more times you do an experiment, the closer it will mirror the real probability. So if you flip a coin 2 times, you might end up with 2 heads. That doesn't mirror 50%. But if you flip a coin 100 times, it's going to be a lot closer to 50%. If you flip it 1,000 times, it's going to be a lot closer to 50%. That's all that means. Probability experiment is any process with uncertain results that can be repeated. So again, flipping a coin would be an experiment because you can repeat it. You can keep flipping the coin. The sample space is a list of all possible outcomes. And an event is a collection of specific outcomes. Specific outcomes. All right, so there's that vocab. Now let's look at it. So a probability experiment consists of rolling a single fair die. So fair just means it's equal chance on all the sides. It's an experiment because you can roll it over and over again and you never know what's going to come up. So identify the outcomes. When you roll a dice, you can get 1, 2, 3, 4, 5, 6. Those are all the outcomes. So the sample space with a capital S would just list those in twirly brackets. An event, even number, now we're looking for the specifically even outcomes from that sample space. So it brings it down to 2, 4, and 6. That's all that vocab is saying. Any probability is going to be between 0 and 1. You can't have a negative probability, and if it's you can't have over 1 because that's 100%. And if you have multiple outcomes, the probability of all of them will add up to 1, making 100%. A probability model lists all possible outcomes and their probabilities. And it has to meet these rules or it doesn't work. So let's look at example 2 here. The color of plain M&M milk chocolate candy can be brown, yellow, red, blue, orange, or green. Suppose a candy is randomly selected from a bag. The table shows each color and the probability of drawing that color. Is this a model? So first we have to see, does it list all the outcomes? So brown, yellow, red, blue, orange, green. So it has all the outcomes. Having a moment here. Okay. Now we need to check rule 1. Are all the probabilities between 0 and 1? So that's positive, 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 positive. They're all positive and they're all less than 1. So yes. And then we need to see if the sum equals 1. So we're just going to add those all up. So 0.13 plus 0.14 plus 0.13 plus 0.24 plus 0.20 plus 0.16 equals 1. So we answered yes to all three of those questions. So yes, it's a probability model. All right. So some different probabilities that you're going to see. Some probabilities that you're going to see are impossible events. If it's an impossible event, the probability is 0. Can't happen. Certainty, or a certain event, has a probability of 1. So together, the closer to 1, the more likely it is to happen. Closer to 0, the less likely. Unusual events have a low probability of occurring. Man. And unless you're told otherwise, we use 5% as that standard. So if it's less than 5%, we say it's unusual unless you're told otherwise. There's 3 ways to calculate probability. The first way is empirical probability. That's through actually doing an experiment. So you roll a dice a bunch of times and you put the frequency or the number of times your event occurs over the number of trials you do. It's also like relative frequency. So for example, here with our example 3, an insurance agent currently insures 182 drivers. Last year, 24 of the teenagers had to file a claim on their auto policy. Based on these results, the probability that a teenager will fly, what is the probability and how many claims would we expect in a given year? So our frequency is the number that filed a claim, that's 24. Our trial is the total number of teenagers. And if you do that division out, 24 divided by 182, you get 0.132. That means we have a probability of 13.2% of our people getting in accidents. And to put that in terms of how many, it's 13 of every 100 would file a claim. That's what we would expect. So empirical is just using the actual experimental data to do it. All right, the data in this table represents the results of a survey where 200 people were asked their means of travel. They could drive alone, carpool, public transportation, walk, other, or work from home. Use the survey to build a probability model for means of travel to work. So to build the model, we're going to do empirical probability. We're going to divide each of those by the 200 people that we asked. So 153 divided by 200 is 0.765. 22 divided by 200 is 0.11. 10 divided by 200 is 0.05. 5 divided by 200 is 0.025. 3 divided by 200 is 0.015. And 7 divided by 100 is 0.035. Now we're going to estimate the probability that a randomly selected individual carpools to work. So that probability would be 0.11 or 11%. And interpreting that would say 11 out of every 100 workers carpools. And then, would it be unusual to select an individual who walks? So the probability of walking to work is 0.025, which as a percent is 2.5%, and that is less than 5. So yes, walking to work is unusual. That's one kind of probability. The next kind is classical probability. So that's what you can do when you know the chances of something happening, but you don't have to flip an experiment. So this is just when you list all the possible ways over all the possible outcomes. So that's how I know if I flip a coin and I'm looking for heads, there's 1 heads out of 2 outcomes. If I'm going to roll a dice and I want the probability of getting a 2, well, there's 1 2 out of the 6 sides. That's classical. You can do it without doing an experiment. You just write down what it is based on what you know. All right. A pair of fair dice is rolled. Fair dice are where each outcome is equally likely. So all 6 sides are the same. And we're going to add together the sides. So to figure that out, on the first die, we could get 1, 2, 3, 4, 5, or 6. And on the second die, we could get 1, 2, 3, 4, 5, or 6. So that's what we could roll on our 2 dice. And then we add them together. So 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 1 is 4, and so on. So you can go ahead and fill this out, or you can just watch. That's up to you what you want to do. 6, 7, 8, 10, 11. So now that I have this filled out, those are all the possible sums I could get. The green numbers, 6 times 6, are 36. So there's 36 outcomes in this table. What is the probability of rolling a 7? So if we look at our 7s, we have 6. So 6 out of 36 are our 7s, which reduces to 1 out of 6. Snake eyes is 2 1s or a 2. So the probability of that is 1 out of 36. And then comment on the likelihood. So if we look at these, the 7 is 6 out of 36, where the 2 is 1 out of 36. So rolling 7 is more likely than rolling 2. More likely than rolling 2. That's how you would comment on that. All right, let's look at another problem. Sophia has 3 tickets to a concert, but Yolanda, Michael, Kevin, and Marissa all want to go. To be fair, Sophia's going to randomly select 2 people that can go with her. So determine the sample space. That's all of my possibilities. So we could have Yolanda and Michael. That's one option. So what did I do? I did Yolanda and Michael. Then we could have Yolanda and Kevin. Then we could have Yolanda and Marissa. Then we have Michael and Kevin. Michael and Marissa. And then Kevin and Marissa. So those are all the groups of 2. That's our sample space. Now, compute the probability that Michael and Kevin attend the concert. So there's 1, 2, 3, 4, 5, 6 options, and only one of them is Michael and Kevin, so that would be 1/6. Calculate the probability that Marissa attends the concert. So we still have 6 options, but now there's 1, 2, 3 of them that say Marissa, so 3/6 or 1/2 is her probability of going to the concert. If we were to interpret that, Marissa has a 50% chance of going. So we're just turning that percent into real world terms. All right, now let's compare these two. Suppose a survey asked 500 families with 3 children to disclose the gender of their children and found that 180 of the families have 2 boys and 1 girl. Estimate the probability using empirical method. So that's using the data they got. So 180 happened out of the 500 they asked. And if I do 180 divided by 500, I get 0.36 or 36%. Now compute the probability using classical. So now we have to do the math out, assuming they're equally likely. So the first child could be a boy or a girl. The second child could be a boy or a girl. And the third child could be a boy or a girl. So this is one way to compute probabilities, is write out all of the possibilities. So boy, boy, boy is one. Boy, boy, girl is the other. And then boy, girl, boy. Boy, girl, girl. Girl, boy, boy. girl, boy, girl, 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 boy, and girl, girl, girl. So those are all of the options we could get. So there's 8 of those. And out of those 8, we want, 2 boys and 1 girl. So that has 2 boys and a girl. That has 2 boys and a girl. That has 2 boys and a girl. So that's 3 out of 8, which gives us 0.375 or 37.5%. So if we look at those numbers, they're not exactly the same. One is found with a sample. And like we talked about before, samples aren't perfect. One is just computed mathematically. And by the law of large numbers, the more people we ask, the closer to 37.5% we're going to get. So if I asked another 500, that 36 is going to be closer. If I asked another 5,000, that 36 is going to be closer. It all just depends on how it goes. But that's the difference between empirical and classical. The third one we're going to talk about really briefly is just when the outcome is based on personal judgment. So as long as someone's judgment is allowed to come into the picture, that's now subjective instead of mathematical. You can't really calculate it. So that's 5.1. There's some more vocab in chapter 5 that we're not going to do homework on, but I just want you to be aware of the vocab. So the first is disjoint or mutually exclusive. Those are 2 ways to say that events have no common outcomes. So they share nothing in common. You can only get one or the other. You can't get both. The addition rule is when you're taking the probability of E or F. So if we're saying, hey, how do I get 2 or 3 on the dice? The addition rule is that you add the probabilities together. And then if there's any overlap, so if they are not mutually exclusive, you have to subtract what they have in common because you've counted it in both groups. And we'll talk more about these as we need them. I just want you to be aware of these vocab terms. The complement of an event are all outcomes not in the event. So if our event was even, the complement would be odd. All the numbers not odd. The way you find that is 1 minus the probability of E. So whatever that event is, it's 1 minus that. Independent events do not affect each other. So E doesn't affect F. Whereas dependent events, E does affect F. The easiest example to talk about is if you were picking cards. Okay, there's 52 cards in a deck. If you put the card back every time you pick, you're replacing it, and the probability is always out of 52. If you don't put it back, so if you're not replacing it, that probability is going to change because the second pick, now you only have 51 cards. The third pick, you have 50. So without replacement is dependent. With replacement is independent. The multiplication rule is E and F together. So what's the probability of getting a 2 and an even number? So you would multiply those probabilities. Find each event, multiply them together. At least probabilities. So if I want to know what's the probability of getting at least a 2 or greater than or equal to a 2, what you're going to do is you're just going to add all the probabilities. So find each probability that's greater than 2 and add them up. Conditional probability is when we look at conditions on the groups that we're talking about. So if I say, what's the probability of getting a diamond given I'm only looking at red cards? That's going to change. So probability of E given F, so that's what that means. E given F, that's what that vertical line means, is the probability of E and F over the probability of just whatever you're given. So a shortcut is, that I remember, is both over given. So you find the probability of both events together, and you divide that by the probability of that specific given, and that will give you the conditional probability. And then permutations and combinations are just different groups of numbers. Permutations, order matters. In combination, order doesn't matter. So we'll get more into that as we need to, but I just wanted you to be aware of this vocab. So that is chapter 5. Let me know if you have any questions.